The software used in the TGF must be accurate in order to properly train pilots and air traffic controllers on the behavior of aircraft in flight. The assumption of a flat Earth can be seen in a publication from the FAA, the Engineering Analysis and Design of the Aircraft Dynamics Model for the FAA Target Generation Facility, TGF. That FAA publication explains the software that is used by the TGF to accurately simulate the behavior of aircraft over Earth. Specifically, this document discusses the detailed engineering design and software implementation of an aircraft dynamics model ADM suitable for incorporation into the FAA TGF simulations at the FAA Williams J. Hughes Technical Center in Atlantic City, New Jersey. The model is designed to be implemented on computers located within the facility and to work in conjunction with software models of radar data links and other air traffic management ATM equipment to provide real-time simulation of aircraft operating within the National Airspace Systems, NAS. The FAA publication explains that in order for the software to accurately replicate the behavior of aircraft during flight over the Earth, the software running the TGF simulator assumes that the Earth is flat. The observant reader will notice that the aircraft equations of motion were calculated assuming a flat Earth, and that we here assume the development frame was the northeast down frame. This implies necessarily that Earth rotation and the variation of the gravity vector with position over the Earth were ignored in developing the aircraft equations of motion. This simplification limits our mathematical model to the flight of aircraft only. The model will not properly handle the flight of suborbital craft and spacecraft such as intercontinental ballistic missile satellites or the space shuttle. The model is adequate for all vehicles traveling under MACH, Match 3, emphasis. Notice that the FAA document both assumes a flat Earth and ignores the rotation of the Earth and gravity. The FAA maintains that the computer model assumes a stationary flat Earth and at the same time remains precise and accurate regarding the flight of aircraft. The only way that a stationary flat Earth can be the basis for a model and that model still be accurate is if the Earth is in fact flat and stationary. That means that the ignored gravity and rotating globular Earth do not affect the accuracy of the model because they do not, in fact, exist in reality.